Multi-model capabilities are baked right into Azure SQL DB. That means you can use graph, JSON, geospatial, and even XML right in the same database. Davide Mauri is here to show us how it works today on Azure Friday. Hello all, here we are again talking more about my favorite topic, data, and I've got Davide Mauri, Program Manager with Azure SQL DB, joining me to talk about the multi-model capabilities in Azure SQL DB. Welcome. How are you doing?
Hey, Lara. Good, thanks, and thanks for having me again. Super passionate about this topic, so looking forward to discuss that with you.
Well, I always love to talk about data, so this is a
Right.
lot of fun for me as well.
Yeah.
So multi-model, tell me more. What do we have in Azure SQL DB that we need to just make people more aware of, and why we would use it?
Yeah, right. I think this is one of the best kept secret that we have, and I really want to share it with the world. Because, yeah, of course, Azure SQL Database is a relational database, but I guess relational database in the last probably 5-10 years have evolved a lot, looking around and seeing what others were doing. And we noticed that developers really need to have more flexibility and expressivity to kind of manipulate modern data, right? So you have JSON document, you have spatial information coming from devices like your phone, my phone, everyone's phone. You have what else you can have? Well, XML maybe it's a little bit old right now, but we can still manage it. Of course, graph models, which are kind of on the rise lately. So we also wanted to make sure that Azure SQL has a more than good supporting graph. So yeah, we actually have JSON, graph, geospatial, and even XML model baked into the engine. So that's something I would like to show you.
I'd love to see this.
Yeah,
Thank you.
so let's start here. So I have prepared some samples here. So regular tables, users, still typical tables, right? But then I also want to give you a glimpse the fact that we can store JSON into a table. So I have prepared some tables to hold user information in a regular way, I would say, very relational. But then also the same data stored into just a JSON data. We store JSON as a kind of a huge string, but then we can make sure that is JSON, so it's a valid JSON by using a function called isJSON that will check, the key are correct, that you are using the quoting, all the JSON stuff. So
if I could just ask, it looks like here you can store the JSON
right.
in the same table as other relational data.
Oh yes, and that's I guess this is what I like a lot, because as a developer it gives me the ability to choose when I want to use JSON because I need flexibility, and when I want to use a more structured schema because I need more logical consistency and performance. So I really like Azure SQL Database because it put me in power of deciding what is the best for me, which is great as a developer because I have my hands free. And just
without a doubt, I'll tell you, I've still got these applications I wrote years ago that I still think about. Oh my gosh, if I would have only had access to this,
right,
I wouldn't have had to do unnatural things on how we store data and access the data.
Yeah, we were pretty inventive at some time.
Yeah.
Yes. Yeah, and now it's easy, right? Let's say, for example, here I'm pushing this a little bit, to the limit, but let's say I really want to go full JSON. For example, I can store into this user JSON table, regular number, relational, let's say, way, but also JSON. And I can store full JSON with, arrays, objects, anything, right? So once I have this stored here, I can start to do all the typical things that I want to do with JSON, like, for example, extracting a value. So I can extract from the row that I'm kind of identifying with this query, the value of the first name, and I will get John. I can extract even non-scalar values, so other JSON. Like, for example, the address is an entire object. And then, of course, if I want, I can then use this object to extract its own data. And then this is where I think things start to be very interesting. I can start to treat JSON as a table and a table as JSON. This kind of mix of the two different and completely opposite behavior that starts to be interesting. Like, for example, when as a developer I manage JSON, usually, the schema is flexible, but is usually always the same. I mean, like an order will always have almost the same properties, right? It's not that the first order has, quantity and value, and the next order has some completely different schema. So JSON is good because it gives me flexibility, but it also, more than times than another, the same structure. So for example, I could extract the key value pair from my JSON using OpenJSON. And this starts to show me that I can treat JSON, in this case, as a key value, or I can even do something more interesting. I can go here and say, I want to open my JSON, and I know that in all my JSON document I will receive, I will have a first name, a last name, an age, and a state, and I can look at it as if it were a table. This is really kind of perfect because I can still have JSON, and I manage JSON when I need the flexibility, but then let's say I need to join this data with some other table that I have stored in a relational format, I can do that now. And that make my life super easy because I think I can say I can have the best of both worlds, right? Flexibility or the more structured schema. So this is an example. I can even nest and open like complex JSON shapes. Like for example, I can open the JSON I have, extract the first name, last name, but then we say that the phone number is actually another JSON, and then I can even extract the nested JSON. So this is just to show that no matter how complex is the JSON I have to deal with, I can easily manipulate and extract any data I want. And as you can see here, I'm extracting the 3 phone numbers that JSON Smith has. And still at the end of the day, I have something that resembles a table, which again, I can use to join, to filter. And the last time we met, we were discussing about the query optimizer. So I can even use the power of the query optimizer, for example, to optimize some of the query that may use JSON. So that's pretty neat, I would say.
Well, this sounds great, and I see. I was just going to ask you, how would you make some changes within those JSON strings that we're storing within the table? Because that data is not always static.
Exactly. And also the last time we were discussing that if I have to move everything out of the database to make changes and then bring it back, I mean, it's complex, right? Mm-hmm. It's complex and expensive. So if I can do some changes into the JSON I already have in the database, that will be great. And in fact, we have created the function JSON modify that literally allows you to do almost everything to your JSON. So you can start from this JSON and, add a new scalar value or even an array. I could insert an array, or I can append to an array. And here you have all the example, and all this repository or all the example will be available in a link that is available in the description. So you can just go and, try it on your own. But basically, we can literally do whatever we need with JSON. But that's only one way to let's say, manipulate JSON, because another way is I want to create JSON maybe. Because let's say now that I have a regular table. So I also have created, in preparation for this demo, couple of regular table where we store the username and the address, right? So it's a one-to-many because, of course, one user may have more than one address. And what I usually would do is execute this query, and I would have a table. Now, as a developer, I'm a little bit annoyed by this table because I have to transfer the table and I have to read row by row, column by column, deserialize it somehow into, or actually put the value in the table into some object I have in my application. And it's quite boring and annoying code. If I could instead ask this query to be returned as JSON, like I'm doing right now, well, my life would be much, much easier because the result set itself will be JSON, and I have many functions in any language, in Node, in .NET, in Python, to easily take a JSON and transform it into an object that I can easily manipulate on Python or .NET or JavaScript, for example. And this is exactly what we can do. We can say for JSON, and automatically Azure SQL will take our query, and instead of returning it into table and rows, we'll actually create an object. And this example, an object created out of this query. So this again, it's kind of the best of both worlds for me because on one side, I may decide that it's still good for me to keep this data stored in a relational format because all people will have a first name, a last name. So it's not flexible. And, flexibility usually come with with a kind of hidden cost in performance terms. So the more flexible you are, usually the more the performance are hard to get. So if I have a well-known structure, I may still decide to have, first name, last name stored in a regular table because they give me all the performance I need. But as a developer, I want to transfer the result as JSON because it's so comfortable for me that it makes my life just easier, make me more productive. And that's exactly what we can do. So literally the best of both worlds. Relational format or JSON, it's up to me, developer, to decide. And I can still have JSON in any case if I want to transfer data to and from Azure SQL. And so I'm super happy. Efficient, absolutely comfortable, great.
And I love that we can store it right in the table with additional relational data. There's so many opportunities for how that can simplify applications or approaches to applications by having that data stored together.
Yeah. It's just about finding the right balance when you need kind of a schema-full approach or a schema-less approach. But I like Azure SQL because it gives developer the ability to choose exactly where the balance is. So you don't have to store everything in JSON or everything as kind of schema-full. So it's up to you to decide. Again, as a developer, I like to be in control of how I want to, shape my application or my data. So that's great. And but honestly, JSON is not the only thing that we mentioned before, right? Because let's say I have JSON, great. But at some point, I realized that I need to kind of represent complex network relationship, like I'm your friend, you're friend of Rob, which is friend of Scott, which likes to go to some specific restaurant. So we have a network of relationship. And lately,
and I've seen this also, by the way, with customers in manufacturing and parts.
Right.
And
exactly.
I mean,
parts,
the power of organizing data in a graph is incredible. Yep.
Yeah, because it makes just more natural and easier for us to see the relationship between the various objects. Yep. So in Azure SQL, now quite a few years ago, we started to still, use the engine we have, which is, again, why we still want to use everything we have as much as possible, because the query engine, the query optimizer, can really help a lot in optimizing queries, any query. So instead of creating something completely new, we simply said, okay, let's say that we can call a table a node or some other table an edge. And if we do that, we can still have the table as a container of data. But then by kind of labeling a table like an edge and a node, we create some special mechanism behind the scene so that this table actually behaves like a graph model. So this means that I can still, for example, create an edge table that connects to nodes by even adding to this table some additional information like a payload, like I like something, but how much I like, from 1 to 5, for example, which is a typical information I want to carry when I say, okay, I like that restaurant. Or I can even, for example, store information about a restaurant, but of course, beside the fact that this restaurant is a node in my graph, I also want to store its name, in which city it's present, and so I still need to have some structure here, which again, table is perfect. Now, honestly, if you really also want to be kind of very inventive here, you can even choose to store JSON inside here. So that's what I like about Azure SQL. Everything we do can work very nicely with all the other stuff we put in the engine. So I could have graph model using JSON data, for example. And then the beauty of the graph model is that, let me go just straight to the point, is that I can use new kind of format to query the data, so that even if I have 10 or dozen of relationship, I don't have to create complex joins, because honestly, relationship could also still be represented by regular table using the joins. But then you will end up having like this huge, enormous query with I don't know how many joins, super complex to understand. And yeah, I think that simplicity and simplifying life is also kind of a way to improve performance, right? At least indirectly. So if we can make the code simpler, it's simpler to manage, it's simpler to maintain, it's easier also to improve and to evolve. So we can use the match keyword here to say that I would like to find all the restaurant that some person has liked. And specifically, I'm focusing on John. So I would like to find the restaurant that John likes. Taco Del, perfect. And then here we can go a little bit more deeper into complexity and saying, yeah, but what are the restaurant that has been liked by a friend of my friend John?
Right.
So, and you can start to build some complex stuff here, like, you know, using this kind of match operator.
So
and with this,
you're really just being able to apply more flexibility to the data that already
Right.
exists and
Right.
just take a different approach to how you might be querying the data, simplifying that
Yes.
for certain, but also adding more power to the kinds of questions you can ask of that data.
correct. And again,
Yeah.
always using behind the scene the ability, for example, for the query optimizer to optimize the query. I can put index on this stuff here. And
Right.
something maybe I can show you in future session is that I can even put a column store index on this to allow fast aggregation of data over graph models, which is, again, something unique, I would say, because if you think what other databases can offer are something very specialized, but then if you need to put different specialization together, you need to move data into other system. Like, you know, there is this system that is specialized in analytics, and some other system is specialized in the graph models. Great, but if you need something that is all together, sometimes it's very hard to find, and that's why we are working so hard in the Azure SQL Database team to make sure that instead you have something that has a bit of everything, which is, I guess, you know, what many developers need. Of course, there are developers that will need something very specific, but on average, I would say the ability to choose is what I would choose, you know, for my project. And here you can see you even more complex.
Yeah, this is fantastic. So, you know, we can leverage the power of storing your data in different formats, take advantage of that stored data to query it in different models. How do I go learn more about where and when I want to take advantage of these features and these capabilities?
Yeah, good question. So here we have samples where you can go and browse. For example, docs.microsoft.com. So you can search for graph. We have several examples. For example, even you know, using full end-to-end solution. So we have another one very famous, Million. This is the Million song dataset. So this is a dataset that represents song liked by persons that you can use, and we have 1 million songs, 50 million likes, 50 million person. So you can pretty much do complex analytics over the relationship of who liked what. And so, for example, if you are my friend and I'm listening to song XYZ, maybe my algorithm should also propose that songs to you because maybe we share the same kind of likes, right?
Yeah.
Well, that's very interesting. But another thing here you may find is, so last one I just want to show to you, is that we also support spatial data. So you can have JSON data, graph data, and also spatial data stored in here using a very common notation called the well-known text format, where you can draw shapes on the earth. And for example, ask Azure SQL, is my bus, for example, close to my home or to my office? Is that bus into a geofence? And you can do everything inside Azure SQL using very simple queries, like this one, for example. You can create a geography and, you know, this, let's say this is the Microsoft Office, this is a bus, and you want to see how distant is that bus from the office. 3 kilometers, easy. And I tell you, I studied, you know, aeronautics at school, and doing this calculation, taking into account the curved shape of the earth, is no joke.
For certain.
Yeah, and the ability to have it in Azure SQL, where you can even create, you know, geospatial index, make creation of geospatial-aware applications super easy. So we are saying, with Azure SQL, you can take data coming from your IoT device, a phone, that may come into JSON, may retain graph data because I liked your song, and you want to also be notified when you are close to me so we can go and hang out together. That's something that Azure SQL can do right away. And that's amazing, right?
That sounds great to me. So thank you again for joining us today and sharing the many different multi-model capabilities in Azure SQL Database. We've been learning all about the multi-model capabilities in Azure SQL DB today on Azure Friday.
Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.